Hello, everyone, and welcome to a third Nordic APIs LiveCast. This is part of our new series where we feature lightning talks from core community members on specific API-related subjects. I'm just going to get my screen shared here. So in today's hour-long webinar, we'll be diving into microservices. Specifically, what strategies platform architects can use to develop and deploy stunning API-driven microservice architectures. My name's Bill Doerrfeld, editor-in-chief of the Nordic APIs blog, and I'll be your host. Here with me, we have a dedicated expert that is very active in the API space, Michael Stowe. Hey, Michael. We were going to have Brian with us today, but it looks like he's unavailable, unfortunately. Hopefully we can get him involved in a future live cast. Just to run a brief introduction on Mike, he's a senior manager of developer marketing at RingCentral. Author of Undisturbed Rest, Michael Stowe has spoken at conferences around the world, an active advocate for creating better architectures and interfaces. His work has also been featured on Programmable Web, dzone, and InfoQ. His past talks and slides are up at mikestowe.com, and you can follow him on Twitter at MikeGstowe. So in his session today, APIs for microservices, he's going to jump back into history to see what worked and what hasn't worked with microservices, look at how to build truly decoupled services, and explore some tools and technologies that make the entire process easier. And this is not Mike's first foray with Nordic APIs. He's actually given a talk before with us. He was involved in the Platform Summit in 2017 with his talk, APIs, Chains, and Graphs. So it's great to have him again. If you're not familiar with the Nordic APIs livecast format, it's pretty simple. We do these 15-minute lightning talks. At the end of each presentation, we'll have a 5-minute Q&A session, and we'll be responding to questions in real time. So if you have one, please comment on YouTube, and we'll try to direct the question to the speaker. If you want to ask questions or leave comments, you need to create a YouTube account, but that's super easy, especially if you already have a Gmail account. Just click Create Channel, and you're done. No real configuration is required. And like I said earlier, unfortunately, we won't have Brian with us today, so we're just going to extend Mike's session a little bit and leave some room for conversation. So first off, before we dig in, I just wanted to share with you some updates from the Nordic APIs world. First off, what is Nordic APIs? Well, we're an international community of API practitioners and enthusiasts. We're doing a number of things. Most importantly, we're hosting some great conferences and meetups, quality events all over the world that are API themed. We're also putting out a lot of content. We run 2 high impact thought leadership style blog posts per week featuring core community members in the API space on their ideas. And we're also publishing ebooks on specific subjects. Coming up, we have the Austin API Summit in mid-June, and this is going to be our second event in the US. We're very excited. We're expecting at least 200 attendees. We've got some great speakers lined up from Square, Cloud Elements, PayPal, Algorithmia, Capital One, and many more. We're also holding the 2018 Platform Summit again in Stockholm at the end of October. And this is our yearly event. It's very well attended. We actually had to upscale to a bigger venue this year to accommodate around 450 attendees that we're expecting to be there. So call for speakers for both events is still open. We have some last-minute spots still available in Austin, as well as we're gathering many speakers for the Platform Summit in Stockholm. So if you're interested in speaking, please submit a proposal, and we'll get back. Also, if you haven't already, I organize a bi-weekly digest. Every time we have 3 articles posted or a new ebook or something else, we deliver some newsletters to our community. So like what Kinlane, the API evangelist, said, Nordic API is invested in educating the community, something that makes their work stand out. We are also holding ebook releases, and our next one is going to be completely microservices themed. So stay tuned for that. So with today's subject, microservices, the term has become kind of a buzzword in recent years. To help evolve business IT infrastructure, it has been seen as the new craze for forward-leaning architects. It's altering the internal composition of new enterprises and is really part of the API-first movement. But are microservices just a buzzword? What are they really about? Well, one way to think about microservices is that they represent the decomposition of monolithic business systems into independently deployable services. This is similar to the Unix philosophy of do one thing and do it well. That one thing is usually a single business capability or the smallest atomic unit of service that delivers some sort of business value. At the end of the day, hopefully, microservice architectures are enabling better speed, safety, and better scalability for businesses. Another way to think about the goal of microservices is through what Chris Richardson says. He says that the goal of microservices is to sufficiently decompose the application in order to facilitate agile application development and deployment. So what we're really getting to with microservices is the core of the individual service. This leads to more distributed, agile, and composable platforms. Some other potential advantages of microservices is that having this decoupled nature ends up in better fault isolation, which can increase the security and availability of services. It also can improve reusability with repeatable components. Being able to have less tech dependency is also a potential advantage. So the individual services have more free will to experiment with different technologies or different programming languages. And a lot argue that it is a more agile approach to development. With many cloud service providers offering so many different services, it kind of makes sense to go with the microservices approach rather than a monolithic approach, because it's matching the complexity of all these different offerings, both on the back end and how they're represented on the front end to consumers. And a great benefit is that it's API driven. Microservices rely on APIs to communicate to one another and to the consumer. But like with most disruptive technologies, there's usually some disadvantages and hurdles to adoption. There can be different issues when it comes to maintaining a microservices architecture and a distributed system. This sort of system may be too superfluous. The complexity might be too wide for what you're really intending. Testing might run into some cumbersome results. Deployment is usually unique. It will require some virtual machine and container orchestration. There's cross-cutting concerns, and controlling identity throughout these different microservices to heighten security will likely require some unique methods. So how do we mitigate these disadvantages or hurdles, if you will, and what strategies can we use to really create great microservices? Well, that's what we intend on looking into today. And it's my belief that through knowledge sharing, by following best practices of others, through tooling, understanding the landscape of tools around microservice development, testing, and deployment, and then through sharing case studies, that we can learn and better our platforms. One unique microservices case study that we featured recently on the blog was that of CIBC. They're a Canadian bank that decided to build a completely homegrown framework for developing all their internal microservices. We reviewed it, and you can see that case study on our blog. It's pretty interesting. Some other helpful articles that I'd recommend you dive into if you're interested in more can be listed right here. One interesting one was Jason Harmon's presentation from our platform summit on a backend for front end. Another one was the asynchronous APIs in choreographed microservices by another speaker, Fran, from a past summit, and some others dealing with how do we create a great backend and a great front end for these services. And like I said, we're working on a microservices themed ebook, so track our progress on LeanPub regarding that. And now up, I'm going to hand things over to Mike Stowe. So I'm going to get off my screen share and we'll get this thing started.
Awesome. Thank you, Bill. And thank you for the amazing introduction. And I still love the Doctor Strange transition there as well.
Yeah, it's to express the infinite possibilities of modern software architecture. You know, it's all planned.
I like it. I like it. So as Bill mentioned, my role is actually marketing. I'm going to try to avoid that. I have 2 marketing plugs. The rest of that I'll try to avoid. The first marketing plug I have, though, and this one's actually probably the most important one, and hopefully everybody can see my screen here, and that is there are 2 very important Twitter handles to be aware of. There's Mike G. Stowe, and that's me. And so if you watch this talk, you think this was a really horrible talk, you just wasted 15 minutes of my life I'll never get back, please tweet that handle, not the other one, because that will get me fired. If you thought, hey, this talk is amazing, feel free to tweet both. I'd be super happy about that. I'm going to do a little bit of recap of what Bill just shared about microservices. And I think the first question is, why microservices? We have this whole process of monolithic software. We have this way that we've been doing things. So why are we changing it? And the first thing we want to do.
Mike, real quick, sorry, we can't see your screen.
Oh, you're not seeing the screen?
No. Let's try something different here.
Let me see. Let me stop sharing and share again. That's why I got moved to marketing, by the way, is I don't know how to use tech. Are you seeing it now by chance?
Yeah, I can see it now.
Okay, I might just leave it in this window. I think sharing it threw things off.
Okay, whatever works.
But we want to kind of change our focus. Rather than saying we want to have a full-blown technical strategy, we want to focus on the business value. So instead of saying, okay, we have a developer who's really good at Node.js, and we have a developer who's really good at PHP, but we're a Java company, everything has to be Java, and we have to use these libraries. Let's let our company or our teams do what they do best and drive value for the company. Let's focus on the strategic goal of what we're trying to accomplish as a whole versus focusing on just a specific project and say, okay, we're going to do this huge waterfall project. We're going to have users. We're going to have payments. We're going to have shopping cart and focus on all that and try to do all that thing. Let's just focus on our overall goal, which is let's create a shopping cart, and then let's have very specific actions that we take with that. Intrinsic interoperability. Basically, we can plug and play these systems anywhere. They can be shared and reused again and again. We're worried more about flexibility than necessarily all the optimizations we can make. And as you mentioned with the Agile, we want something that we can work on over time and iterate on it and get better. Let's get to 80% there and then work on the rest of the 20% versus, again, that waterfall methodology of saying, let's get everything perfect and out the door in one shot. So that's what we're really trying to accomplish as we move this direction. And as Bill mentioned, the idea then is to create self-contained, composable, decoupled services. Again, services that value logical representations of a business activity with a very specific outcome. It's self-contained, it's autonomous. You can make changes to the service without impacting everything else. It may or may not be composed of other services. In the microservices camp, we have some different views on this, on whether it should, be truly independent. But the reality is most services are going to rely on other services, and it's abstracted from consumers via an API. You're not going to be talking to the service directly. You're talking to the API, which acts as an intermediary for the service. Of course, we have to jump in as we talk about APIs to Dr. Fielding's 6 constraints for REST, one of them being a layered system. We want a layered system. We want to have a layered system where the consumer, the client, uses the API. The API goes into the business process layer, which calls into service, which then goes down to the data layers. Basically, again, a very agile system where if we need to change one of the layers, if we need to change the data layer, for example, it doesn't necessarily impact the API or what the client sees. In other words, services are loosely coupled units that are self-contained. They do one specific action. Maybe it's booking a flight ticket. Maybe it's a user system. But again, they're microservices. They're really defined. And hopefully what I'm saying so far makes sense. And hopefully everybody's looking at this going, this sounds great. We want these decoupled systems that are autonomous that we can spin up in a container and take down as needed. Because it's really, really revolutionary in a lot of ways. But before I continue, I have to do a quick thank you to the SOA manifesto for their definition of SOA, or service-oriented architectures, the Open Group for their SOA definition, and of course Wikipedia for telling us what SOA is. And the reason I want to start off this way is everything we're talking about with microservices and everything that we're looking at saying, we want to be decoupled, we want to have an abstraction layer, we want them to be minuscule by themselves. We've actually already tried once. We created this concept of service-oriented architecture, and when we did this, we ran into some just conglomerates that today we're still struggling with. I remember talking to one company, and to change their SOA, or the original microservice architecture, it was going to cost them $12 million. And Sam Newman, in his book, Building Microservices, lays out some of the problems that SOA had. He said, I think the big problem is actually the communication protocol. For example, SOAP. The vendor middleware, a lot of vendors got involved and said, we're going to solve this problem for you. Not knowing where to split up your application for granularity. Kind of issues like that, which the reality is these are all issues we run into with microservices as well. What constitutes a microservice? What about the communication protocol? Does REST solve the problem? Does GraphQL solve the problem? The reality is SOAP could have worked as an abstraction if it had been an abstraction, but it was extremely tightly coupled to the underlying architecture. The other problem we have is that no matter how you build your architecture, something must be glued into it. We talk about microservices and we say, we're just going to spin them up and spin them down. Something still has to connect one microservice to the other microservice. And if you think about it, the traditional way we do that is we say, we're going to bring in a CRM. And that CRM has an API, and we're going to connect that API to our 7 applications. The problem is it's not just one CRM, and it's not just 7 applications. The average enterprise has 75 SaaS services they connect to, not to mention numerous applications that need to talk to each other. And what that means is the second we try to change something, we now have to update 7 different applications for every application we have. Again, if you think of the blue problem as Legos, when you connect 2 Legos, I say I want the blue Lego, ripping them apart is really easy. It's really easy to get rid of that blue Lego. We have 3 Legos, and I say, okay, get rid of the green Lego or change the green Lego. It's really easy to rip that out and reconfigure. And then we get to the third figure where now we have more services all tightly coupled together through their APIs, which are tightly coupled to their architectures. And we say, okay, rip out the green one. And unless you're going for that very top green one, it's very difficult to do. And that's the thing that we have to be aware of is as our systems grow, no matter if we're using SOA, no matter if we're using microservices, they become more complex. And eventually start looking at something like this. When I talked about the conglomerate, this connection issue for SOA or microservices, this is exactly what companies like MuleSoft, Tibco, Informatica, Cloud Elements are trying to solve. But the reality is, again, this is a really bad representation, because if you look at microservices today, they look like this. You have Amazon's ecosystem, you have Netflix's ecosystem, and then you take on tools like Docker, Kubernetes, and Istio, which are all very powerful and great tools. And all these dots start going up and down, and you have multiple routing mechanisms, and you have version 1 and version 2. But again, each one of those lines, there's still glue that connects them together. If you integrate an API that's tightly coupled to its underlying service, you're basically integrating that service. Again, going back to that one graphic, we pull up that CRM. Even though we were using that CRM's API, because it's tightly coupled to the system, we have to change to 7 applications. Again, I cannot iterate this enough. Something must be glued into your architecture. This is inevitable. And the very basic tenet of microservices is services should be designed to fail. You should design the service so you can spin them up, spin them down. APIs cannot. Your API cannot fail, because every time your API fails, you have to update across the 20 different applications or dependencies. APIs are designed rather to unglue services. So again, if we look at that same CRM, and this may seem silly, but by putting an API in front of it, by creating our own API layer, which again, tools like MuleSoft, Cloud Elements help you do, you can actually decouple the service from your architecture. In this case, if we change our CRM, maybe we go to ABC CRM, all we have to do is change the backend logic of our API layer. We don't have to worry about changing what the client sees and how it communicates. So again, we're able to plug and play our microservices and pull them out very simply. This means that we have to be very cognizant that the biggest risk to our architecture is not our service. Again, services need to be designed to fail, but rather how the services are integrated into our architecture, which means it's the API or our abstraction of it. And I like saying that designing an API is very, very hard. You're building an API, there's plenty of services that do that. You can use frameworks for almost every language. Designing the API, that's a whole different challenge. So if we think of APIs as Legos here, I want you to imagine, because this is actually how we build APIs for the most part today. If APIs were Legos, you have this beautiful Lego city that you want to build. And by the way, this is actually my hometown city of Oakland. And you can tell it's Oakland because the bank is being robbed. Disclaimer, again, I live in Oakland. Beautiful city, love Oakland. Please don't send hate mail. But we have this great city that we want to build. So we start off with the best of intentions, but we don't have the instructions. We know what we think it should look like. We have an idea how to get there. So we start building it brick by brick. And we have to make some decisions on the fly. We say, okay, maybe this brick goes here, maybe this brick goes here. And finally, we are ready to take our beautiful city to production. We're all done, we're good to go. And voila, we have this beautiful city, which took me about 3 months to build. This is actually my city I'm very quite proud of. But the point is that what you really want to glue into your architecture? Because that's going to force your architecture to change. That's going to cause you to have that glue problem. And that's going to put you in the same situation that we ran into with service-oriented architectures. Instead, we need to make sure we're taking a step back to understand and design the API. And this really sounds like common sense, but this is one of the most missteps of building an API. You have to understand who your API is for. Is it going to be used internally? Is it going to be used by multiple services or one service? Just by that question, you can decide, should we be using a SOAP API? Should we be using an RPC API? Should we be going with the constraints of REST? Or maybe I want to use GraphQL. GraphQL, by the way, I think is a great query language. I think the team did an absolutely amazing job with it. But keep in mind that GraphQL is very tightly coupled to the model structure and isn't designed to give you the same flexibility that REST is. And so when you're connecting multiple mechanisms to it, you can actually get yourself in trouble by being too tightly coupled or essentially recreating SOAP. How are you going to maintain your API? What about documentation? And then what about things like authentication, provisioning, preventing attacks? Again, microservices are great, and this idea of moving to containers is tremendous, but the attack surface exponentially increases. So not only do you look at tools such as Envoy or Calico for, your protection of your connections or requests, but how do you prevent misuse on the API itself, or somebody accidentally creating an infinite loop and unintentionally causing a DDoS attack? Take advantage of spec-driven development. Spec-driven development means that you're going to define your API before you write a single line of code. It also means that you can mock out your API, test it, and get user feedback. And the way it works is essentially as two agile cycles. The first agile cycle is the design cycle before you write code, and the second agile cycle is the development cycle where you start writing the code to the design. The way it works again, design, you're going to design the API, you're going to mock it, you're going to get feedback, and decide, does this meet our needs? Is this a good design? And have we thought through all the kinks and bugs that could really jam us in the long run? And once you have, then you move into development. If in development you realize we have some technical debt or an issue, you can always go back to the design cycle and solve it that way. But by using this design cycle, not only can you ensure that everything's consistent and is the same, but you can actually do things like create test-driven unit tests, do test-driven development to make sure your API works as you build it. There's a lot of great specs out there today that you can use. There's the RESTful API modeling language, or RAML, which is the second most popular specification on the market. You have Mastery's IODocs. IODocs was kind of the initial leader in this space. I'd recommend not using IODocs just because Mastery's not really focused on them anymore. They've actually moved to Swagger or the Open API Initiative. Swagger Open API Initiative is another great spec, has a lot of great tooling, huge community, and does a lot of the same things for the spectrum development that you want to use. And API Blueprint is a really good language for documentation, but I really strongly suggest taking a look at Swagger or the Open API Initiative or RAML. The great thing about both of these specs is you get a designer with them. So you can actually see what the API would look like as you design it, and you don't need to write any code. Again, in the case of RAML, I'm creating a resource called followers. I'm giving a description. I'm adding a get method, a post method. I can do all this without writing a single line of code. And then I can mock this out so that people can actually try the API. They can actually build applications based on the API. And one of the great use cases is we had a customer that fell behind on API development. They created a specification, they mocked it out, handed to their mobile team, and actually did parallel development where they developed the API at the same time they developed the mobile application. It's really important to note that a poorly designed API is going to cost you far more in the long run, and it's going to add months to fix. It's kind of like security. You either build the API the right way in the first place, or you're going to pay for it significantly down the road. And usually the significant pay for it is our API is broken, it's stuck, we can't extend it, we need to build a brand new API. The second thing to be aware of course, is using best practices, as Bill said. For us developers, that means don't reinvent the wheel. Incorporate nouns, take advantage of CRUD, return header codes, return descriptive error messages. So using nouns, you should never use verbs when you're using REST full practices. So if you're modifying a resource, the resource should be called users. Also try to use plural whenever it can be plural. So for example, if you have one address, but there's potential for it to become numerous addresses, use addresses just to avoid confusion. Take advantage of CRUD. The important thing here is, again, as you use the HTTP methods for a RESTful API over HTTP, know the difference between post, get, put, patch, and delete. Know when you'd use a post versus a put to do a create. Know what the difference between a put and a patch for an update is. And I'll share some more resources on that soon. Take advantage of response codes. I try to stay out of politics, but I will pick on the White House. I disagree with them on the recommendation to use just the 200, 400, 500 status codes. Use all the status codes. Take advantage of 200, it's okay, 201 is created. The first number tells them whether it's a success or a failure. The next two numbers tell them exactly what happened and what they need to fix. If they don't have the right auth token, give them 401. If they don't have permission to access the page, give them 403. Or if you're feeling really creative, you can use my two favorite, which is 418, I'm a teapot, and 420, enhance your calm. To be honest, I don't really get the 421, but that's neither here nor there. Also take advantage of descriptive error messages. When you give an error, tell them what happened, but more importantly, tell them how to fix it. So tell them you're missing user ID, tell them why they need the user ID, but then give them a link that explains, here's how you fix the problem. So right back to your documentation. Again, you don't have to reinvent the wheel. There's some really great formats. There's vnd.error, Google errors, and then JSON API, which is a hypermedia spec, actually has their own error format that you can use separately. Use hypermedia, and the catch here is actually use it. Hypermedia is something we all use every single day. If you're watching this on YouTube, you're using something called the World Wide Web, which is written in HTML, or the hypertext markup language. Hypermedia is simply an extension of hypertext. It's the ability to link and say, here's what you can do with this item, or here's the next step. Hypermedia is designed to remove the business logic from the client. And this is the part that we've really missed with hypermedia. The client shouldn't have to guess what they can do with the API. They shouldn't have to write their own rules to try to adhere to your business rules. That should all be handled server side. So if you think of us having 3 users, we have Mike Stowe, who's a super user. We have Joe the spammer, who is caught spamming, and Bob Jones, who's a standard user. We have different capabilities for each. The responses would then say, oh, for Mike, here's the 3 things you can do. For Joe, here's the 2 things you can do. And for Bob, here's the 4 things you can do. Again, lots of great specs out there. You can take advantage of HAL, JSON API. Those are the 2 most popular ones. But it's literally just putting a link in saying, here's the next step. You want to edit the user? Here's a link to edit the user. You want to get their messages? Here's a link to get their messages. This one's kind of obvious, plan for change. Versioning is a necessary evil. Do not build your API with the plan to version it. Versioning creates numerous problems. The first being that you never get rid of a versioned API. If you think you're just going to deprecate the API and be done with it, does not happen that way. You're always going to end up supporting version 1, version 2, version 3, probably internally as well as externally. Versioning also means that you have to rewrite all your dependencies. So all those 7 applications, or in the real world, 1,000 applications, have to be rewritten when you version your API. Again, when we look at APIs and evolvability, it means you have to be able to add, remove, or modify features in the system without changing the interface. And again, your API is the interface. And Roy Fielding, who I love when he goes on a rant, says, I said we don't need to version the interface. The interface should be standalone, which is why we have to design it so carefully. Take advantage of accept and content type headers. The reason for this is technology changes. Right now, JSON is the thing, but you might have a legacy customer that needs XML, and you might have new technologies that you need to support, such as YAML or pipes or whatever it may be. I can't believe I just said pipes as a new technology. By building this into your API right away, when those requests come, you don't have to refactor the entire API or build a brand new API. You can kind of support those out of the box. Number 5, be sure to document. Please, please, please do not be that developer. The easiest way to kill an API is through lack of documentation or bad documentation or out of sync documentation. I've actually consulted on API projects where they want to build a brand new API because the API documentation was wrong. Again, the business guy didn't realize that we just had to update the documentation and everything great. They just knew the API wasn't working. And again, if you're using spec-driven development, it should be really easy because you have the spec and you can use an open source project to generate your documentation in less than 5 minutes. This is a quick script for RAML where you get your query parameters, you get a try it now functionality, you get code examples, all without writing a single line of code or having to build your own documentation, all from that spec you created initially. All right, I think the next step is the most important step of all. Read my book. This is my second shameless plug or my second marketing moment. You can get my book at mikestowe.com/books. The thing with this is, this isn't to make money. If you go there, there's a sponsored download, so you can download the full 200-page book for free. Or if you go to Amazon, I think get the Kindle version for like $2. But there's a lot of good practices in there. Otherwise, API Nordics has so many good resources on API best practices and how to design API. My blog has more resources. Brian's gonna have a lot of great resources. Be sure to check those out. And with that, I'm going to do something I very rarely do, which is I'm going to stop talking.
Awesome. Thank you, Mike. Yeah, I like how you describe microservices as Legos, but personally, I'm more of a connects kind of guy. I think their ecosystem is less prone to theft. Hopefully, I like to think.
Well, the reason I like Legos is because I feel like microservices, when they're done incorrectly and they get scattered on the floor, are just as painful.
True, both can be very painful. But yeah, more seriously, some really great insights on the entire API design lifecycle. Like you said, poorly designed APIs are going to cost way more effort in the long run. So covering everything from error codes, hypermedia, versioning, documentation, like you said, all those different numbered aspects, I think are really important. Kind of bringing the focus back to how we design microservices, if we're thinking about, building those kind of contained, isolated services with our APIs. Where's the line of decomposability, do you think? Like, how small should we be thinking when we're designing services?
So myself, it's funny because I was actually at a microservices conference where the person said this whole thing of microservices has gone, ridiculous. Analysts are now calling them nano services, mini services, and
quirk services.
One of the proposals that was made at this conference was to move towards macro services, which is kind of, again, repeating the wheel. I think a microservice should be a service that is confined to a specific function as it makes sense. So if you think of, we have users. I could see user service. I would not have a service that edits users, and a service that gets user information, a service that adds users, because I feel like you're just trying to, open Pandora's box and have different models and schemas. So I do a user service where it's okay. This service will, I can add a user, create a user. Shopping cart's a great example. You can have a wish list. To me, that's a service versus trying to build it into a cart service. Payments is a service. So again, it's kind of that thing where you have to split it, but I believe you go to the smallest denominator without having to split up something that makes sense together.
Sure. And I've seen microservices kind of partitioning things as it makes sense to the consumer as well, especially if it's, more public facing. So I guess it just kind of depends, and using, common sense and your best judgment.
Mm-hmm. The other thing too is, like with the microservices, I believe in layering them. So taking a layered approach. For example, your database should actually have its own microservice that connects to it and is the interpreter. So that if you say, look, we're using a DB2 database system, and we're connected to our user microservice and our payment microservice, but now we want to go to, I don't know, Mongo. You don't have to go to those services and change it. So if you have a service that kind of is the database microservice for the DB2, you rip out DB2, you put in the Mongo database, you update the backend information. The front end API is still the same. You're still doing, the CRUD. You're doing a post into the or an insert into the database, updates, deletes. Again, that way you're only changing one service instead of having to change a bunch. So if there's overlap between the services, that's when I think it really becomes its own service.
Right. Yeah, that makes sense. Lastly, I kind of wanted to hit on this thing you're talking about, agile, kind of replacing the old waterfall development style.
Mm-hmm.
How do you think it's possible to balance those two extremes when we're talking about the process of microservices, when we're having these development teams, we're having these conversations, we're having some sort of governance? What have you seen in the wild?
So I think the biggest mistake, and not that I'm opinionated by any means here, but I think the biggest mistake with Agile is we came in with this idea that it's going to create less documentation. And the reality is Agile requires more documentation. With Agile, you're creating your user stories. You're actually putting together a full list of what you want to do. The difference is that list is fluid. So you can add in new stories. You can change the prioritization. And you're not saying, let's build everything and then test it at once.
Right.
the other mistake I think is people got away from the 7 plus and minus 2 rule, and so it's like, oh, we're gonna have agile team of 40. That doesn't really work. You have too many cooks in the kitchen. So I think when moving to it, obviously, anytime you move from waterfall to agile, it's a very painful process. I think you have to very clearly explain the benefits up front of we're still documenting everything. We still have the story. The good news is we're going to do unit testing and test-driven development. And, we're going to do quick releases where instead of saying we're going to build a whole application and find out if it works, we're going to get out there and deliver. The problem with Agile with APIs, though, is we've taken that to an extreme of saying we're just going to build the API, get it out there, see how it works, and then we'll make changes. The problem is that doesn't work. And there's a big social media site. I don't want to say their name so I don't get sued here. But they have a resource. I'm going to call it the user resource. I don't know exactly which resource it is. But to search the users by age, you have to put in a very specific JSON schema to search by age. If you want to search by location, you have a very different JSON schema for location. And if you want to search by age and location, there's a third schema you have to use. And what happened is you had basically 3 different developers building these components, doing it agile, let's get out there, and not having a design or a plan. And that's where we see APIs get stuck is, I like to joke that we're really bad at design. And most people are like, no, I'm great at design, I'm the exception. And I say, if you look at your code, think of how many times you're in code that you're super proud of, and look at a year later, are you still that proud of that code? It's the same thing. We extend a class, we're like, this is amazing. We extend a class again, like, this is wonderful. We extend it the 3rd time and it breaks, and we're like, I have to refactor everything. And that's the problem with APIs is you have to know what you're building long term. And that's why the design is you can actually test it out, mock it, and find those issues before they hit production. Because unlike an app where, okay, we hit production, we found a bug, we'll fix it. An API, you put it out there, you can't change it because you've created a contract that your consumers are using.
Gotcha. Yeah, great insights throughout the entire life cycle right there. Thanks, Mike.
No, thank you.
Yeah, in summary, endnotes, look into HTTP error code 420. That's on my list of to-dos. And watch out for Joey the Spammer. Sounds like a bad guy.
The spammer is a bad guy. He's trouble.
We actually did have Brian join in, which I'm very excited about. Hey, Brian.
Hey, can you hear me?
Yeah, sounds good.
Great. Sorry about there.
Oh, no worries. It's good to have you on board. I'll just do a brief introduction on you. I have your bio here. Yeah. So Brian is a senior staff software engineer at Cloud Elements. He's a software engineer spending his time designing, developing, and maintaining services and infrastructure at Cloud Elements. His interests include building scalable, reliable, secure, and maintainable software systems. This is actually his first speaking engagement with Nordic APIs, so welcome to have you. In his session, Microservices and Serverless at Cloud Elements, Brian is going to discuss the journey of the Cloud Elements transition from monolith to a serverless microservices approach. He's going to describe their motivations and methods, things they did well, challenges, and important lessons they learned in testing, deploying, and integrating APIs and microservices. So yeah, looking forward to that. And take it away. I just want to say to viewers who are in real time right now, please comment, ask some questions. We'll be happy to take them at the end of Brian's presentation, and then to both presenters at the very end of the live cast. So yeah, I'll just switch things over to you now, Brian.
All right, thank you, Bill.
Sometimes the screen share can be a little tricky.
Yeah. All right, can you see that?
I see it on your screen. There we go.
Okay. All right, is that still displaying?
Yeah, it looks good on my end.
Okay, cool. Yeah, so like Bill said, at Cloud Elements, the engineering team has, for the past year or so, been going through a migration from our original legacy monolithic architecture to a hybrid microservices serverless architecture. So I'm gonna talk a little bit about what Cloud Elements does, what our product does, and how changes in that product and changes in our usage kind of drove this decision to move towards a microservices architecture. Also, when we started this, we kind of wanted to, we knew we were getting a fresh start, so we wanted to define what we valued as an engineering team. So I want to talk about that a little bit, what we discussed there. Also, just talk about what approach we took and progress we made in moving from the original architecture to our new one, as well as some lessons that I personally learned with some things that were challenging to us. So yeah, why did we undertake this journey? So originally, so Cloud Elements provides a API integration platform, and we have I think over 150 connectors to different service providers. We call these things elements, and we organize these into categories of service providers that all do a very similar thing. And we provide an API abstraction. So we have a unified approach for authentication, error handling, pagination, search, to all of these different connectors or elements in this hub, we call it, which is the collection. So that was our original product offering, this uniform API that just would help our customers accelerate integration to cloud services. So that obviously, as products do, that product evolved to include a few things. We allowed users to define their own connectors. So through a UI tool, they can write their own connectors that operate within our platform and connect to new cloud services. We also added things like virtual data models, which include a common schema to map API payloads for the service providers. As well as transformations to transform from the vendor object to a common object that the users define. And of course, as soon as you allow that schema, the customers start asking for, little bits of glue, like I can't quite transform this thing exactly like I want it. Could I just write a little JavaScript? Yeah, just more user-defined logic came into our platform. Another thing that our product evolved to offer are things like reusable orchestrations. So when an object changes in one service provider like Salesforce and you want to sync that to your Microsoft Dynamics system, our product evolved to offer these reusable workflows that when something happens, you can go through a series of API calls, other little JavaScript glue things, and sync data from one system to another, or do all sorts of things. It's a very general purpose thing that it allows. So yeah, our original monolithic architecture was designed to support that first use case, that uniform API that are grouped in categories, just driven by connectors. Originally, these were connectors that we at Cloud Elements developed and maintained and controlled what those did. This was pre-user-defined logic, all that stuff. So it was a pretty simple monolithic architecture. Requests came in and were load balanced across. It was a Java-based Spring application. It provided both our platform APIs to control our domain objects, as well as vendor APIs. Those API calls that go out to the service provider ultimately. And it also provided our user interface, so it did it all. It was just a single application that did it all, backed by a single relational database. Because we were doing just one thing, this architecture worked great for us. Scaling this thing as load increased it was manual scaling, both in the vertical direction and horizontally as load increased. Deployment of this application was manual, tedious, error prone. Our dedicated hosts were definitely pets, not cattle. They each had special names, and they were groomed and taken care of each individually. So we had, snowflake hosts, basically. And that was fine. Like it worked well because our product was only doing one thing when we just had the uniform APIs. But as we kept adding on these dissimilar product features, the events coming in from the service providers, all these different asynchronous types of workflows, we just stacked them into that existing service. I think this is a pretty common pattern. This is the story that a lot of places that have gone through a microservices migration. It's a pretty common thing that you hear. So yeah, not only were we stacking these different product features into our single monolithic service, but we were also adding all sorts of data stores to support these things. Events were ingested into our system, and we would queue them up in a message queue / event stream. We used Kafka for that, so we could work them off asynchronously later. And that was fine. We were using Elasticsearch for storing our system logs. And as our load increased and our relational database started to show signs that it wasn't going to hold up, someone had the bright idea to start throwing customer data, customer objects into the Elasticsearch as well. So we were using data stores for multiple different purposes. We had a need for caching, so we threw Redis out there, but all of these were integrated with our single monolithic service. And all of these platform features that we were adding, they had dissimilar features, like different rates of customer demand. Some things like our event ingest would be, all customers would use that. Other things like the workflows, it would be just a handful of our customers had very high load on our workflow feature, whereas others would run one every couple hours. So different rates of customer demand, also different rates of resource consumption. These, especially the things that we provided that allowed our customers to write their own JavaScript or define their own connectors. We have no control over that, so we don't really know if a script that's been running for 60 seconds, 90 seconds, if that's ever going to finish, or if that's a legitimate call that's just taking a long time. So these different product features were using resources at different rates as well. Another thing that was different about these different product features was the rate of change. There were some things that were fairly static. Customers weren't asking for feature enhancements on them. Other things, they were either full of bugs, or customers were loving it, and we were needing to add new features at a high rate. So yeah, all of this kind of boiled down to unpredictable performance and reliability in our monolithic service. Along with that, we had a couple of other drivers. As our load increased, our reliability was decreasing. We would have out of memory errors in the service, and that would impact all API calls when it was just like event processing or a workflow execution that was really causing the issue. We were having test and quality issues within our monolithic service. This is a picture of the test snow cone. You've probably heard of the test pyramid, where your greatest number of tests are at the base, where you have a large number of unit tests followed by a much smaller number of full end-to-end tests. We had the anti-pattern of that, which is the test snow cone for our monolithic service. and that was causing some test and quality issues. We were also racking up a fair amount of technical debt, and along with that, we were experiencing low developer velocity. So all of these things were kind of our, we looked at these and said, okay, how do we deal with this? And the response was, well, microservices architecture is supposed to take care of a lot of these things. So let's look at that. So we knew we were kind of getting a fresh start with moving to a new architecture. So along with that, we wanted to define what we valued as an engineering team. And they were tied pretty closely to the issues we were seeing, the issues with scalability and reliability, issues with quality of the software products and testability of them, as well as developer velocity. So we went through this process of kind of defining what we valued, and then from that we extracted some practices that we wanted to focus on as we developed these new services. And this is so there's a talk that a guy named Brian Cantrell from Joyent gave at Node Summit this past year, and it's called Platform as a Reflection of Values, and it kind of talks about this same deal. So I'll provide a link for that at the end of this talk. There's the O'Reilly Microservices Architecture book by Sam. I apologize, I forget the author's name, but there's a chapter in that book called The Evolutionary Architect, and it talks about this as well. So it was a really good practice for our engineering team to sit down, define what we valued, define what our goals were for this microservices architecture migration, and decide what we want to do. So a couple of the practices that we extracted from those values are, pretty standard microservices stuff. Small, focused services that are scaled independently. We hoped this would take care of some of the issues we were having with scalability. Just the opportunity to have technology heterogeneity. This would just, we hoped would free us to make the right technology choices for the type of load that we expected each service to encounter. And this plus the ability to choose the language that we want for a given service, not be stuck with the existing Java language that we were using in our original service. Not that there's anything wrong with Java, but just giving us a wider range of options. To address our quality and testability issues, we thought that doing things like full test coverage on our services, automating everything that we can, automating linters, automating find bugs, stuff like that. And finally, velocity. We hoped that having focused teams, focused on one thing, not getting pulled in 100 different directions, fully focused on a service at any given time would help improve velocity, as well as things like continuous integration, continuous deployment would help improve our velocity. So, So yeah, what was our approach in kind of breaking down our existing architecture? We took somewhat of a domain-driven design approach where we organize our services to align with our product features. Some of the things I mentioned earlier, events coming in from a service provider. So we broke out an event ingest service to do that for us. Other service providers don't provide webhook events, but in those connectors, we wanted to still provide the event features, but we have to go out and pull them. So breaking out that event polling feature as an individual service. So yeah, just aligning those product features with our services. The second aspect of this was integrating with other services via well-defined APIs. Mike just talked a lot about this, so I won't focus on it. But for our services, we've got we've got kind of two different sets of APIs. The first is synchronous APIs, which are just like kind of domain object management type of things, where we use REST over HTTP with JSON payloads. Pretty standard REST. We utilize the verbs and nouns as Mike discussed. The second type of APIs, and I kind of use APIs loosely in this case, are asynchronous event-based orchestration type of APIs. So the event ingest service I mentioned earlier, all it does, it's a tiny service. It receives webhook events in, and it dumps them onto our message queue to be processed asynchronously. So that, but that interaction through that message queue, that's also somewhat an asynchronous event-based API. It's an agreement between those two services on what that payload is going to look like. The third kind of thing we tried to do with our microservices approach is provide common features in a common way. And Bill kind of touched on this in his intro, but just things like don't reinvent the wheel for each service. Like every service has to log. You have to provide some sort of monitoring for each service. For debugging, you might want to trace a single API call through your entire system. Things like authentication. All of these things, all services have to handle for them. So we hoped to not bake that into every single service we had, but rather provide for those features in a common way. And finally, introduce a little bit of discipline into our software development through things like testing. I mentioned before, maybe I didn't mention before, but one of the practices we decided on is 100% unit test coverage. 100%, every single line, every single statement, every single branch, everything is tested, and that's more just like a baseline. That's just assumed with our services. On top of that, we do service level testing, where we isolate a single service and its data stores, mock out everything else, and test it that way. Also introducing a little bit of discipline in our versioning, both of our not so much of our APIs, but more of the software itself. We use semantic versioning for everything, so our versions actually mean something. When one of the three numbers in the semantic version is incremented, you know that you kind of know what that means. So yeah, just we had hoped to introduce a little bit of discipline into our development process with this as well. So as we started this, we started breaking out a few services. The first services were just driven by desperate need. Basically, our legacy service was falling down because we would have a large volume of events come in, and we couldn't keep up with those API calls, even though we were just taking them in and dumping them right onto a message queue. We had to get that out into a smaller service to scale that thing independently. I mentioned user-defined scripts. Originally, when we implemented that, Java has a built-in JavaScript execution engine called Nashorn, but it's not really JavaScript. So that was like our first attempt at script execution, and it was just a mess. So we had to get something that was actually running JavaScript scripts. So we built a tiny little script execution service. So yeah, these first services were like totally need-based. Like our platform was failing, and we had to get them out. Kind of just as an example of what one of these things looked like. They were, most of our services, our microservices, are Node.js. We decided to go with Node.js because two reasons. We had experience on the development team with JavaScript development already, and Node.js and NPM, just there's loads of good quality modules available to do anything. So there was, it was a good starting point. And yeah, so that's what we went with that. the APIs for these things I already mentioned. Synchronous was REST over HTTP. And I already mentioned how we handled testing with these. The deployment, we kind of swirled a little bit with the deployment of our services. We started with just standalone hosts, similar to how we had deployed our original monolithic service. We moved towards Elastic Beanstalk and had a lot of issues there. Basically, it's great. It was great when it was a service that didn't need much customization to the host. But as soon as we needed to tweak something, increase the number of file handles or something, then Elastic Beanstalk was a little bit challenging. Finally, we've started moving towards containerized Kubernetes-based deployment of all of our services, and we've had a lot of success with that so far, and we're continuing with that as well. With the monitoring of these things, we swirled a little bit there. We had several things that were all kind of integrated. Datadog was one of the things we used, Monet, as well as custom scripts. Now that we've started moving towards a Kubernetes-based deployment for all of these things, we've been able to standardize on Prometheus, which is a pretty commonly used monitoring solution for Kubernetes. Integration we had challenges with as well. As soon as we started, we had grandiose ideas for co-developing a Java client along with each service that we developed, that so we could release those things in lockstep, but that never really panned out. So we've struggled a little bit with coupling in our integration. I think the approach that Mike laid out with spec-driven development would have helped us hugely. Just spending a little bit more time focusing on the contract between two services before jumping right in with both feet and defining these things. So yeah, as we started developing more services, we ran into what everyone who does microservices kind of runs into. As soon as we had multiple services that needed to know who the caller was, we didn't want to bake authentication into every single service. So a common solution for that is an API gateway. So as soon as we had multiple services, we had to add an API gateway to the platform. And then it's hard keeping authentication data at the API gateway in sync with whatever the source of truth is for user authentication. It's just more difficult. But having an API gateway in our platform also helped us solve some of the issues I mentioned before with trying to provide common features in a common way. This was one of those situations. The API gateway now provides authentication for all of the services that respond to public API calls. It also provides audit logging, which we need for to both provide to our customers as well as for compliance reasons. Since all API calls go through one common gateway, we solve that problem in a common way as well. I mentioned issues with integration before. When you move towards microservices, you try to loosely couple things, but keep things related all in one place. So it's just a difficult problem to solve. Another part of this integration is, again, Mike touched on it, is the API versioning. Semantic versioning, again, has helped us here a little bit. But we've started looking at when we increment an API version on a service, which, defer it as long as possible, because every consumer of that service then has to change. But we've done a couple of different things where we either deploy multiple versions concurrently. So we're running 2 versions of each service, but then you have issues with data migrations. Like if your database schema has to change, you have to, you can only add things. Basically, you can't change existing things. Otherwise, the old API version breaks. You can also do things where both API versions live within the same service, the same deployed service, but it transforms the older version of the API into the newer version of the API. But all of these things are just hard. They're just hard problems to solve, and it's more difficult as we add more services. So along with this, yeah, the more services you add, the more operations and deployment issues you have. You have to collect logs for everything. You have to monitor everything, and just as these things scale out, it becomes more difficult. Finally, I've mentioned a few times about user-defined logic, the user-defined connectors we have, user-defined transformations, JavaScripts. So this has been one of our more difficult problems to solve. So the approach we've taken is there's a few challenges, right? So you're running untrusted code. This code can, as I mentioned before, you don't know how many resources it's going to take. And when you have these issues and you have these things happening within a multi-tenant application, you get noisy neighbor problems where your heavy hitters are impacting other customers, and the overall performance of your platform is really impacted. So the solution for us has been serverless, and there are a lot of commercial applications that provide this serverless functionality, and AWS Lambda is one of them. We looked at pretty much every commercial offering, and because for one reason or another, typically it was execution limits. I think Lambda has like a 5-minute limit on executions, which seems generous, but for our requirements, it just didn't meet them. So we looked for any open source function as a service platforms that existed, and at the time when we started, there was basically nothing, and the things that were there were very immature. Nowadays, there's a lot. OpenFAS, Fission, OpenWhisk. There's a lot of function as a service platforms that are available, but at the time we decided we needed to build our own. But if you know anything about serverless, a big draw for serverless is reduction of operational complexity. And when you're building and running your own function as a service platform, all of that benefit goes away. So we gained a lot with this. We were able to prevent the noisy neighbors. We're able to isolate resource consumption to a single customer. We're a lot better equipped to sandbox these executions where they can't reach out and get into our internal network. So we gained a lot of things there, but at great cost of building and maintaining our own serverless platform. So yeah, I think we've been pretty successful in aligning our the results that we've realized from our migration from a monolithic to a more microservices and serverless architecture. We've made a lot of gains in scalability and reliability. We're hitting our SLAs a lot more easily now. Yeah, our quality and testability are much higher. Velocity, I mean, we can do releases now in minutes versus days or weeks with our old architecture. So yeah, it's been a really good experience, and but we've got a ways to go. So so yeah, I'd also like to just mention a few things that I've learned, things I would do differently. So when we started, we had the option of either doing greenfield development with our new services or basically extracting existing functionality from our existing service. If I was given another chance, I would have taken the extracting existing functionality route over the greenfield development. This could be different depending on different circumstances, but and with with extracting existing functionality, there's other challenges like whether you're going to share the data store once you pull out that functionality, and there's issues there as well. But yeah, it was just something to consider. Another lesson I learned, I'm kind of calling it principles versus pragmatism. So there's things like, so don't repeat yourself. So we took this a little bit farther than we should have, I think. We had kind of standardized on Node.js services, and we didn't want to repeat the same thing in our Node.js services because, they all need health checks. They all need some way to spin up worker processes if you're running on a multi-threaded system. So we baked all this stuff into a package that all of our services would extend from, and it led to a lot of coupling where changes in that parent package would kind of trickle down and require us to rebuild and redeploy all of our services. So one of the rules of thumb I've read is, don't repeat yourself is fine within a single microservice, but when you try to do it across multiple microservices through like shared libraries or something like that, it just becomes a little bit hairy. Another thing with trying to be pragmatic, one of our big drivers that I mentioned was the polyglot approach, where we can choose any technology we want to accomplish the job at hand. And this is fine until you kind of get into the operational complexity of everything. Like wanting to use a different data store is fine, but then you have to know how to deploy that data store, monitor that data store, and if you're abusing that data store, you need to be able to respond to it. And it requires higher levels of operational experience. So, and even managing a JVM-based service plus a Node.js-based service, they're different runtimes. Like they each use memory differently. So, the more services you have using different technologies, the more difficult it becomes. Another mistake we had was in our team structure and resource allocation. When we started, we were like, here's the 10 services we want to build. And there were like 5 engineers working on this. So we each got one service to start on, and we kind of spread ourselves too thin. So I've heard of the Amazon's pizza team, where team shouldn't be any bigger than you can feed with 2 pizzas. We had the 2 slices of pizza team. So we just spread ourselves a little too thin. And that's continued today. A year later, there's only ever one of us that has experience in running a single service. So we're kind of on call for those things all the time. And then operations, as I mentioned before, it just becomes more difficult. And yeah, we're continuing this journey. As I mentioned, we're moving towards a Kubernetes-based deployment from our other deployments. We've been going through a huge push of security and compliance, getting our HIPAA certifications and all this stuff. We've just reached the point where we can do some level of self-service operations. We actually had someone from the customer support team develop their own service and deploy it into our platform recently. So that was a huge win there. And yeah, moving forward, I think we'll, rather than the shared library approach that kind of caused us issues with coupling, we'll move more towards like a template, a service template that someone can start with to again just enable autonomous teams. So yeah, it's been really interesting going through this, and it's been somewhat successful, but also super challenging, as I'm sure is common in teams that go through this. So yeah, that's all I had.
Great, thank you, Brian. Yeah, really good case study on why a company would want to segment services in this way. I mean, you talked about many of the struggles you had originally with dissimilar product features, your asynchronous workflows, all the different data stores, varying resource rate consumptions you had going on, and testing and quality issues, and all the tech debt, etc. The test snow cone, I mean, it sounds so delicious, but it's not at all. Yeah, really appreciate you taking the time to present with us. I'm also glad that you focused, on your internal stack, like what you're using, for, whether it be Prometheus for monitoring and Kubernetes or whatever have you. And I think the lessons learned are really valuable, so that a lot of people can relate, privileging reusability over complete greenfield development, for example.
Yeah.
I'm wondering which benefit, what value do you think is going to resonate most with engineering teams throughout, a microservices transition?
For us, our rally cry the whole time was scalability. Like all of us that were on the team, we were also the the 24/7 operations team. So we were carrying the pager and getting pinged at 3 o'clock in the morning when things would go down. So yeah, it was like a desperate attempt for us to regain our 8 hours of sleep at night to
Awesome.
to go through all this.
So things are more reliable now, and
yeah,
more secure, and cool. And maybe you have better automated, monitoring now to watch over everything, so that you can sleep at night.
Yeah, you do. And the great thing about moving towards Kubernetes is it's a lot more self-healing. Like when we had the individually managed hosts that ran the service, which we still do for our legacy service. We're not there yet with that. But with that, you lose one of the servers and you lose X percentage of your capacity to handle load.
Right.
Whereas with Kubernetes, and it's not unique to Kubernetes, but it's more self-healing. When something dies, it just replaces it with another copy of it. So.
Right. You also mentioned more services, more problems, and kind of the downsides and potential struggles on this transition, whether it be like writing that new script execution service you mentioned, or kind of getting the whole team on board with the philosophy of how things are working with development. Mm-hmm. You mentioned some deployment like nuances, as well as monitoring and identity issues. So what do you think is like the hardest struggle for your team in all this transition after everything you mentioned?
Yeah, I would say it's still the culture of quality type stuff.
Yeah.
Yeah, it's really easy to talk about the benefits of having 100% unit test coverage. And when I went through it, when I developed a service and made myself do 100% test coverage, it makes you write it differently. It makes you write it in a testable way. But having someone start and they get to 90% test coverage easily, and getting that last 10%, you have to refactor half the service. That's a tougher sell.
Right.
So getting everyone on board with those types of requirements is challenging.
Well, thank you for sharing everything today. Was really interested also to hear about proper pizza consumption levels based off of team size, and I'm hoping that the next state of integration report is more pizza heavy from Cloud Elements. So send that up to the higher ups, please.
Will do.
Yeah, I think that's it. I don't think we got really any user comments. For our listeners who did tune in, thanks for sticking around. I knew we were going to do it a little bit earlier, but this all worked out just fine. I'm going to do some wrap up slides real quick. Can you guys see that?
Yep.
Cool. All right. So, yeah, we're still figuring this out. This is our third live cast. I'm hoping to do a lot more in the future. Thank you for Curity. They're a continuous Nordic API sponsor. In the future, you can follow Nordic APIs and all of our updates on events and new articles and live casts at Nordic APIs. That's our Twitter handle. And then we also have a new Slack channel where the community is starting to discuss API best practices and design ideas. So check that out. And like I said earlier, we have some great upcoming conferences. The first one being the one on the right there, the Austin API Summit in mid-June, and then the yearly summit in October in Stockholm. So call for papers is still open for both, so please submit. And if you're interested in participating in one of these, we're definitely open. Contact us at info@nordicapis.com. And yeah, that's it. Thank you to our speakers for today's live cast. And all the resources that were mentioned, we'll try and include in the show notes below the YouTube video. So with that, I'll sign off and say thank you.